Vanadium pentoxide.
Vanadium pentoxide acts as a catalyst in the contact process to convert sulfur dioxide into sulfur trioxide.
Lowers the activation energy required for the oxidation. A reversible exothermic reaction.
Sulfur dioxide and oxygen gases are passed over a catalyst bed of vanadium pentoxide that is heated to 450 degrees Celsius. These conditions allow for a high efficiency oxidation of the sulfur dioxide.
Created by burning sulfur.
Resulting in an output of sulfur trioxide. This is then absorbed by concentrated sulfuric acid to give us a thick, gloopy oleum. This can be thought of as over 100% sulfuric acid, although it is sulfur trioxide dissolved in sulfuric acid, and it does things that sulfuric acid can't.
Y is a mouse. When is things.
It is a powerful dehydration agent. It can even react in an explosive way with moisture. It is a rapid sulfonating agent. It is required in the aromatic dye industry. Spill some and it will eat through your clothes in seconds.
Oleum is diluted with water to produce high purity sulfuric acid.
Through the carboniferous foam, ole, 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 oleum.
Concentrated sulfuric acid, preferably 98%. We are going to drip this onto phosphorus pentoxide. This is how phosphorus pentoxide reacts when it touches water.
This is now warm.
Phosphorus pentoxide, as I mentioned in my video about phosphorus, is considered one of the most powerful desiccants known. It doesn't just absorb water, it chemically binds it, forming phosphoric acid. One drawback is that phosphorus pentoxide cannot easily be regenerated once reacted. That's why more practical desiccants for routine use include magnesium sulfate, calcium chloride, or molecular sieves. They are weaker but can be reused. Another strong and chemically reactive desiccant is sodium metal, which is used for drying ethers and hydrocarbons. Close in strength to phosphorus pentoxide is calcium hydride. This reacts with water to release hydrogen gas, making it another aggressive but useful drying agent. If we want something even stronger than phosphorus pentoxide, that would be sulfur trioxide, the compound we're making today. For sheer dehydrating strength, only sulfur trioxide surpasses phosphorus pentoxide, but it's far less convenient to handle. These substances are at the extreme end of the scale. They don't just dry samples, they can destroy them.
The short path condenser, positioned like this.
I'm going to measure the temperature of the condenser water because We need it to be a bit warmer than this. 25 is good. I will now open the stopcock so that the sulfuric acid will drip on the phosphorus pentoxide, where it will release sulfur trioxide vapors, which will condense in our 25-degree condenser and collect in the test tube. Sulfur trioxide fumes in air and it reacts strongly with water.
Drip. Drip. Very tiny bit on the end of the spike.
The sulfur trioxide made here is dissolved in
Little snuggling.
concentrated sulfuric acid.
It will dissolve.
This results in a more than 100% sulfuric acid, oleum.
Keep it on the down low. Down to Bismuth. Science freaks.
Okay, to try and make this easy, we'll stick nitrogens up here. Flip this the other way.
Enzymes and biological structures are held together by bridges of calcium or magnesium. EDTA moves in and steals the metal bridge. Without the metal glue, the organic compound, like a bacterial cell wall or a DNA strand, falls apart. This makes EDTA an effective preservative and lab reagent, even though it isn't bonding to the organic parts directly. The nitrogens in EDTA are excellent at hydrogen bonding. Acidic environment, EDTA grab proton. Will it chelate? Transition metals? Yes. Lead, copper, iron, mercury.
Alkaline earth metals.
Yes.
Calcium, magnesium.
Non-metals.
No. Carbon, nitrogen, oxygen, chlorine.
Anions.
Negative.
No. Sulfates, phosphates, nitrates.
Organic molecules. DNA.
Indirectly, by removing their metals, the nitrogens are blind to anything that isn't a positive electron-hungry center. If a compound doesn't have space for electrons, the EDTA nitrogens simply float past.
If you remove all 4 acetate groups from EDTA, you get just ethylene diamine. Watch my last video to see me make a copper complex with this.
Son,
Father?
bring the bismuth nitrate.
Here it is.
Her con night,